through some of this, and I want to make sure that you really understand and track what's going on. All right? It's not a straightforward process. There's some complexity to it. But it all boils down to our basic fraction arithmetic. If we think back to normal fractions, normal ratios that we've been dealing with forever. If I have common denominators, what's 2/3 plus 4/3? 6/3. Can I simplify this to 2? The idea with rational expressions, with adding and subtracting, is the same. But instead of integers, we have polynomials. But we're still focusing on making sure our denominators are common. And when we're simplifying, looking for common factors. Okay? Looking for common factors. Now, once I add in uncommon denominators, I need to find a common denominator. The least common multiple would be 15. Well, how do I turn a 3 into a 15? Multiply by 5. Is that the only thing I'm multiplying by 5? And the numerator. How do I turn a 5 into a 15? Multiply by 3. So then I get 10 15ths plus 12 15ths to add 22 15ths. So the process is the same. The values will be different. Okay? So let's get into it, the nitty-gritty. All right? Rational expressions with common denominators, just add your numerators, keep the denominator. Okay? We're going to fly through the first ones because they're pretty straightforward. All right? Same denominator, right? The denominator stays the same. Add your numerators. What's a plus 3a? 4a. 4a. Can I simplify that ratio?
Yes.
Yeah. By what?
2 divided
By
by 2.
2. 4 has factors of 2 and 2, and then we have the a. 6 has factors of 2 and 3. So the common factors of 2 eliminate, leaving me with 2a times 3. B has common denominators. X plus 6. Now it's subtraction. What's the difference of my numerators? Squared minus 36. Not a trick question. X squared minus 36. They're not like terms. I can't subtract them as they are, so I just write both terms with the operation. Now, can I simplify this? How? I can't simplify those yet. Notice how these were common factors, right? 36 is not a factor. 36 is a term. How do I know it's a term? The subtraction sign. 6 is a term because of the plus sign. Same with the x squared and the x. Those are all terms. As I have it now, I don't have any common factors. So what can I do to get common factors? Square. So I can factor it. Factor your polynomial any and all that you can, and then look for common factors. So I've got a difference of squares that always factors to be x plus and x minus. What's the x plus and the x minus? 6, because it's the square root of 36. Note now, common or factors. I have factors. Factor of x plus 6, a factor of x minus 6, and a factor of x plus 6. What do they have in common? The factors will eliminate, and leaving me with x minus 6. I'm going to be repeating these vocabulary terms a lot, over and over and over, because I need you to ingrain what they mean and associate them with the differences on the equations and the expressions. X squared is a term. 36 is a term. X squared minus 36 is a factor. X is a term. 6 is a term. X plus 6 is a factor. I can factor my numerator into the factor of x plus 6 and the factor of x minus 6. That grouping, that multiplication, that's factors. Okay? Say denominator, nice and easy. 2p plus 7. Now add the numerators. Good. 7p plus 3p gives me, or 4p plus 3p gives me 7p. Negative 3 plus 8 gives me 5. Do I have any common factors? Is 7 a factor? No. It's a term. So I don't have any common factors. Can I factor either of those? No. No, there's no GCF.
So that's the answer?
That's the answer. There's no simplification. There's no common factors, and they can't be factored. So that's already in lowest terms. Subtraction. What's my denominator going to be? Y minus the same. What's my numerator going to be? 8y minus 16. It's a cubes. Squares. Because the y is not squared or cubed. 16 is not a cube. Factor out 8. I've got a GCF in my numerator. What's 8y divided by 8? What's 16 divided by 8? I factored out the GCF.
I see.
Okay. Now do I have any common factors? Yeah. Y minus 2. So what's my answer going to be? 8. Okay. Deep breath. It's going to be okay. All right. Common denominator. That's good for us. Let's go ahead and factor them. Okay. Actually, let's subtract and then we'll factor. Okay. We've already got a common denominator. So I've got y squared plus 3y minus 10. What's my numerator? 3y minus 6. Now let's factor both our numerator and denominator. How can I factor the numerator? GCF of 3. I factor out the 3. What am I left with? Y minus 2. Okay. Now denominator. I've got a trinomial where the leading coefficient is 1. So I know it's going to factor in the form of y plus or minus something, y plus or minus something. What are those two somethings? Good. Positive 5 and negative 2. Use your numerator as a hint. If I'm going to simplify something, I need one of the factors down here to be y minus 2. Okay? It doesn't mean that one of your factors will definitely be y minus 2, but use it as a hint that that is highly likely to be 1. So check to see if negative 2 works. Negative 2 times what gives me negative 10, and adds to 3 is a positive 5. So that helps us find those two factors. If it doesn't work, don't force it. Okay? If it doesn't work, don't force it, but you can use this as a kind of a hint or cheat sheet to see, well, let me check this one first, because that might be one of them. Okay? What's the common factor? Y minus 2. So I'm left with 3 over y plus 5. Having fun yet? Alright. Here's fun. Okay? So, just like our fractions, we need common denominators. If I don't already have a common denominator, I need to get the common denominator. LCD and LCM, just know those are the same thing. Okay? Least common divisor or least common denominator or least common multiple. They mean the same thing. Least common denominator or least common multiple. Alright? So, we need to look. See, they're not the same. Okay? So I need to find the least common multiple. So a couple things to note. 1, I've got 7a, which is factors of 7 times a. I've got 6a, which is factors of, go back, of 6 times a. All right? So, to find the least common denominator, all right, first of all, if they have anything in common, well, that's part of it. Because they're going to have a denominator, they're going to have A. Okay? It's going to stay there. But I don't need it twice. Okay? So I've got A. But 7 and 6 aren't the same. So I need the least common multiple of 7 and 6. 42. Multiple. So it's going to be a number larger than that. So 7 times 6 gives me 42. That's an easy way to find a least common multiple of an integer. Multiply them together. It's not always going to be the least, but it's going to give you a common multiple that you can use. Sometimes it might be a number that's smaller. Okay? But multiplying them always works. And this is something we're going to be doing more with the polynomial, so knowing that process doesn't hurt. So I have A and I have 42, which was 7 times 6. So they both have an A, and I got 7 times 6. So that's my least common denominator. So how do I take 15 over 7A and make the denominator 42A? Multiply by 6. Am I just multiplying 7A by 6? Numerator 2. But now, the problem. I'm taking my fraction. 15 over 6. I want my denominator to be 42A. My fraction by 6 over 6. So that this becomes 42A. I can't. Okay. 15 times 6. Good. Okay. Now let's do the other side. So I got plus 8 over 6A. What am I multiplying this one by? 7. 8 times 7. 56 over 42A. Add them together now. 46 over 42A. Can I simplify that at all?
Yes.
Not by 4. 2. Again, make sure you write it in lowest terms. If you don't write it in lowest terms, you're not done. Okay? Alright. Now let's move from monomials to binomials. So remember with the last one, 7A was factors 7 and A. 6A was factors 6 and A. When I have a binomial, my factor is that binomial. So my first fraction, fraction 1, has factors of just x plus 3. That's it. That's its only factor is x plus 3. My second fraction, fraction 2, has a factor of x minus 3. That's its only factor. Okay? So they don't have anything in common, unlike my first example, right? They had the A in common, so that was an auto include. But they had 7 and 6 that were different. So to find the LCM, what did I do with 7 and 6? I multiplied them. So they have these factors unique. So to find the least common multiple, what am I going to do with them? Multiply them. Now don't actually multiply them. Just write that you're multiplying them. Because you don't want to expand it. You just want to note that those are the two factors that you'll have in your denominator. If you multiply, you're just going to end up having to factor them again. It takes extra time. Okay? So the factors that we need for the common denominator is going to be x plus 3 and x minus 3. Okay? So now we look at our two fractions. And I'm putting some space in here on purpose. Space in there. Alright? I look at my first fraction, I have x plus 3. What is it missing from the least common denominator? X minus 3. So just like we multiplied by integers, I'm going to do the same thing, but I'm going to multiply by the binomial, x minus 3. So now I have that fraction with that denominator. My second fraction is missing what? X plus 3. So I'm going to multiply it by x plus 3. Okay? Again, don't multiply your denominator because you're just going to have to factor it again. So just leave it. Okay? X plus 3, x minus 3. Leave it, leave it, leave it. But because I've got, okay, but because I have multiplication and addition in my numerator, I need to simplify everything, which means I'll have to do distributive property and then combine like terms in order to simplify it. Because it's not factored, I've got addition in there. So multiply 4x minus 12 plus 5x plus 15. And then we want to simplify. Okay? What like terms do I have in my numerator? Oh, I forgot an x. Let's square. There we go. 5x times 3 is 15. What like terms do I have in my numerator? 15x and 4x, which gives me what? 19x. And the other two terms don't have any common factors. And make sure that ringer's off. So 5x times x is 5x squared. 5x times 3 is 15. Distributed property. Now, we would try to factor our numerator, but I took way too much time last period figuring out that it's prime. So, it's prime. So we can't factor. It's already in simplest terms because the numerator is prime. If the numerator could be factored, you want to factor it and check for common factors to simplify. I've added in an example that ends up with common factors, so we'll make sure that we have that covered. Okay? Having fun yet? Thanks for the pity, yay. All right. Now, this one's a little bit nicer. Pay attention to if you have opposite factors. I've got 2x minus 6, and I've got x, that's 6 minus 2x. They're opposites because one of the 2's is positive, the other one is negative, one of the 6 is negative, and the other one is positive. So, if I have opposites, I can factor out the negative 1 to change the sign. So I can take my first fraction and change it to be negative 1 times 2x minus 6. That switches those signs, and now they're the same. I can make it even easier. Fraction equivalency. If I have 3 halves, a negative 3 over 2, that's the same as 3 over negative 2, which is the same as negative 3 over 2. Those are all the same. So the placement of that negative 1 does not make a difference in the value of the expression. I can move it to the top, I can move it to the front. So, just to get me to my common denominators quickly, because the only thing that's different right now is that negative 1, I can make that negative 1 times 3 over 2x minus 6, which is just negative 3 over 2x minus 6. Now their denominators are the same. Now that the denominators are the same, I can go into subtracting. 5 2x minus 6 minus negative 3 over 2x minus 6. Denominators match. What's 5 minus negative 3? 5 minus negative 3. 8. Okay? Can I factor either of those?
Yes.
Which one?
2x.
Yep, factor it by what? 2. mu is x minus 3. Can I simplify now? So you will factor the numerator to be this. Makes it easier to see what you can cancel. What can I cancel? I can cancel out the 2. That's a multiplication, not negative. That way it's clear. Okay? Woo. Okay. Alright. Are my denominators the same? No. Factor them. Okay? So, let's factor x squared minus x minus 6. That's going to give me what?
6, negative 1, and positive 5.
That won't give me a negative 1. I need to add to negative 1. Factors of negative 6 that add to negative 1. 3 and what? 2. Any of them positive or negative? 3 is negative. Because I want a negative 1, right? Okay. So there's my first one. And then let's do x squared plus 5x plus 6. Factors of 6 that add to 5. Positive 3 and positive 2. Okay? So now I know what my factors are. Do they have any common factors? X plus 2. That's an auto include in our least common denominator. Okay? Now, anything that's unique, we also have to include. Okay, so remember, going back to when we had 7a, which was 7 times a, 6a, which was 6 times a. They both had the a in common, so that's part of our denominator. But then I had to multiply the two things that they were missing, the 7 and the 6. So I'm doing the same thing here. The things that each one is missing also get multiplied in. So my denominator is those 3 factors. So then looking at my first fraction, which factored form is x minus 3, x plus 2, what is this fraction missing from the least common denominator? X plus 3. So we're going to multiply it by x plus 3. And then we do add x over x plus 3, x plus 2. What is it missing from our least common denominator? X minus 3. Okay? Got it? So again, my denominator stays the same. That's already set for me, so that's nice. So now it's just a matter of simplifying your numerator. I have this being multiplied and then added to the product of these. So distributive property. 4 times x, 4 times 3, 4x plus 12. X times x, x times negative 3. Good. Simplify our numerator. Combine like terms. Does x squared have any like terms? No. Does 4x have any like terms? 3x, so that would give me just x. 4x, negative 3x, 1x. Okay? 12 is the last thing. Okay? So x minus 3, x plus 2, x plus 3. And again, our numerator ends up being prime, so that's already in our lowest terms. Leave it like that. Alright. I add it in another example. Okay? You ready? Do that. Why didn't it show up? Okay, so here's our new example. Our last one. So write this somewhere. We want to take 2 over x plus 1 and add it to 4x squared over x squared minus 1. Alright? So, factor x squared minus 1. X plus 1, x minus 1, because we got a difference of squares, right? So, this becomes x plus 1, x minus 1. Alright? We want to identify our least common denominator. Is there anything that they both have in common? X plus 1. Is there anything that they're missing? X minus 1. So this one just becomes our least common denominator. It's similar if I was trying to add the fractions 1/4 plus 1/8. My least common denominator is 8. So I don't need to change my 1/8. I just need to change the 1/4 to match with the denominator of 8. Same thing here. My second fraction already has all the factors in the LCD. So I don't need to change that one at all. But I do need to add it to my first fraction. So I'm going to take 2x plus 1 and multiply it by the x minus 1 that it is missing. Okay? But my second fraction does not need to change. It already has the common denominator in its entirety. So there's no change to the second fraction. I'm not done. So what's my first fraction going to end up being? So 2x minus 2. I don't understand why there's conversations going on when I am talking. And then my denominator stays the same. Okay? Plus 4x squared, x plus 1, x minus 1. Okay? Leave our denominator. And then add our numerators. 4x squared, 2x minus 2. Okay? Now I need to factor the numerator. I can factor out a GCF of 2. Alright, so I'm coming up here. I have 2. Leaves me with 2x squared plus x minus 1. Okay? Now I need to continue to factor 2x squared plus x minus 1. What multiplies to give me negative 2, but adds to give me 1? Multiplies to give me... Say that again? That won't multiply to 2, but you're on the right track. One's going to be positive, one will be negative.
Oh, 1 and negative 2.
So
Negative 2.
Positive 2 and negative 1. So I've got 2x squared plus 2x minus x minus 1 over x plus 1, x minus 1. Okay? Factor by grouping now that you split that middle term here and here. So I've got 2x and then x plus 1. And I've got negative 1, leaving me with x plus 1. Don't move, I ain't done. You can wait the extra minute. Okay? Finish your numerator. 2x minus 1, x plus 1. Denominator, x plus 1, x minus 1. Do they have anything in common?
Yeah, x plus 1.
X plus 1.
Just keeps going.
So your final answer is 2x minus 1 over x minus 1. Okay?
Very